Today on Math Spark, we have the topic of variations. So let's start with direct and inverse proportion. Direct proportion, two quantities are involved, and if we have an increase in one quantity, as a result of its impact, the other quantity also increases. Like over here in the example, we have number of sandwiches. If someone is buying one sandwich, the cost here is $0.5. But as the number of sandwiches increase, the cost also increased, right? So it means the number of sandwiches are directly proportional to the total cost. So this kind of proportion where both the quantities are increasing, it is called direct proportion. In some of the cases, if both the quantities are decreasing, then we call it. We have an example here. Again, example from 3 packets of sweets cost $12. How much will 10 packets cost? Okay, we can have an idea. Method one is your unitary method, but generally, method two is more applicable. Here we have arranged our given quantities in a proper order. Packets on left side of the equal to, and the cost or the uh, money on the right side. So 3 packets cost $12, 10 packets cost Y. Then cross multiply. We must remember when it is direct proportion, we cross multiply in direct proportion. This is the most important thing to remember. Okay, when two quantities are directly proportional, we cross multiply them. There is another example here about here the quantities are petrol in liters and the traveling. Again, it's in direct proportion question, so we cross multiply. How we come? It's very important to assess about the proportionality. Now we have some more questions here. What is the cost of 9 apples? If 4 apples cost $1, means we need to arrange it into the proper order and then do the cross multiply. A cyclist travels 30 kilometers in 1 hour. How far does he travels in 20 seconds? Now, the most important thing over here, let's try out this question. A cyclist travels 30 kilometers in 1 hour. How far does he travel in 20 seconds? Most important thing to note down here is they are asking us in seconds. So our quantities should be in the same way, kilometers and seconds. 30 kilometers in 1 hour, how many seconds are there? We need to check it out. In 1 hour, there are 3600 seconds. Now, how far does it travel? So x should come here and 20 seconds should come here. Next, we need to do the cross multiplication. So in case of cross multiplication, 3600x is equal to 30 into 20. 3600 can go and divide on the right side. We can multiply 30 by 20 also, but as far the easier way is this, if we leave it like this, it will easy for us to cancel the zeros cut by zeros. We have got 3 to the 6 means simplifying it further 6 upon 36. Okay, so x is equal to x is equal to 1 upon 6 kilometers. We can change it into meters. Hope this thing is clear. Okay, let's move further. Next, we comes with the concept of inverse proportion. Inverse proportion, again, there are two quantities. While comparing those two quantities, if one quantity is increasing, as a result of it, the other is decreasing. That is called as inverse proportion. Like here, number of workers are supposed to paint a house. If one worker is taking 12 hours, if the number of workers are increased and it's the same house to be painted, so it will be the time is going to reduce. Similarly, as more workers are increasing, the time is decreasing. So this kind of proportion that where one quantity increases, the other decreases as the impact of it, we say this is an inverse proportion. Okay. Let's move on about the inverse proportion. Now check out here an example that a pack of rice for 20 men can last for 12 days. How long would the pack of rice last if there are 30 men? The very first thing, we arrange those quantities into an order. Now if you check out one important thing, the red arrows. The red arrows tell you that the straight multiplication. Hopefully you remember in direct, we have the cross multiplication. In inverse proportion, we have the straight multiplication to get our answer. Okay, there is another example here. You remember there was a question in direct proportion where we converted to get the same unit. So here also check out, it's 2 hours given, so we have converted it into minutes because in the first quantity was in minutes, 75 minutes, so we cannot write down hours below the minutes. We need to change that 2 hours into 120 minutes. How 120 minutes? Because 1 hour is equal to 60 minutes. The 2 hours will be 120 minutes. Here are some of the practice questions with the explanation. I am sure students can try them. Now, here are again some challenging questions. In these challenging questions, it's written direct oblique inverse proportion, means they might be from the direct concept or they might from the inverse. So go through the situations, check whether each situation tells you which kind of proportion is this. Okay, what we have discussed in the previous slides were direct and inverse proportion with the given situations from examples from around us and from the daily life. Now, let's come to the numbers. We are going to turn this concept of a direct proportion into the formula. And we consider that y is one quantity and x is another quantity. This might be numbers, this might be our given situations. So when we say that y is directly proportional to x, this is the sign of proportionality. To remove the sign of proportionality, we make it that y is equal to kx. Now here this k is the constant of variation. Fine. And like this, we got the formula y equal to kx. This is also known as k method. This concept is also known as k method. Okay, there is an example to understand the same thing which we have done earlier also. Here they have explained you hourly rate, but generally when the K method questions comes, this is an example to understand, but generally things are directly in numbers. Direct proportion, let's go through some statements of direct proportion. Y is proportional to x, y equal to kx. If y is proportional to the if y is proportional to the square of x, then it will be y equal to kx square. If y is directly proportional to x cube or cube of x, we can say y equal to kx cube. Y varies directly with the square root of x, y equal to k root x. Okay, these are the four statements. Some important point to note from these statements, the wordings. When it's a generally student get confused that in the question it's written y is proportional to square of x, means they have not mentioned its direct or inverse. If it is not mentioned, it means they are talking about the direct proportion. Okay. The next student get confused when somewhere they see the word y varies directly with the square, which is again one and the same thing. Okay, these four statements are telling us how to make the formula. Further, they are telling us what vocabulary can be used in the questions. So this thing must be clear to us. Okay, let's move to the next one. Okay, there is an example here for how to solve a given question with direct proportion with K method. Okay, y is proportional to the square of x. Okay, the very first thing we have written y is proportional to x squared. Then again, using the sign of proportionality, y equal to kx square. Filling in the values, we get this 9 because 3 square is 9. Next, how we get this 2? This 9 is dividing. So 9 ones are 9, 9 twos are 18. That's how we got k equal to 2. Okay, moving on to the first step. Directly we have got y equal to 2x square. Let's check out how we have got it. We have got this formula y equal to kx square. So basically y is equal to kx square. In step 1, we have got the value of k as 2. So it will be y equal to 2x square. Fine. Then substituting the value as in our a part, it was given. So we get 5 square 25 inserting. Next thing, y equal to 2x square. Hopefully, we know from where this 2x square came. Then filling in the values, we get 98 divided by 2 gives us 49. Gives us 49. Then how we got 7? We have taken square root of 49. So square root of 49 gives us 7. That is how we have got this answer. Okay, let's move further. Okay. Inverse proportion or inverse variation with the K method. We have already seen the direct proportion with the K method. Similarly, we can solve out inverse proportion with the K method. Here it comes. In this case, y is equal to k upon x. Concept of the inverse proportion remains the same. Here we have an example. Y is inversely proportional to x when x equal to 3, then y equal to 6, find value of y when x equal to 8. Inversely proportional, you remember we started. So here y is inversely proportional to 1 over x. Then y is equal to k upon x. Filling in the value, we got k equal to 18. Next, making up the formula y equal to k over x. Our value of k is 18. So it comes y equal to 18 over x. Filling in the values, we get the answer after inserting our values. So that is how we solve the question of direct proportion and the question of inverse proportion. It's the summary, a quick recap. If the question is of direct, we are going to do y equal to kx. But if it is inverse, then it is y equal to k upon x. And if the question carries y is proportional to x square or x cube or cube root of x or whatever, then accordingly we are going to give x as our power. And there, this is the graph for the basic proportionality. For the direct, we have got a straight line graph, and for inverse, you can see this graph. Hope the concept is clear. Best of luck.